Hi, this is Strong Kim, and welcome to Chess in Ruby version 2, part 4. I have to write it down because I have a hard time remembering. All right, so let's go take a look at the code and see where we left off. All right, so ambiguous move because it has to recognize if you make a move that we should eliminate any moves that will uh, put you in check. All right, so um, let's make a very simple test. So in here, the context is, let's see, all right, so what is the context? Castling? No, no, not castling. Um, check. My mind is not very clear right now. Okay, so um, check for check. Hmm. I don't like any of the names that I'm coming up with. Um, validate for check. Okay, that sounds pretty good. So we'll set up a position where um, the move should be invalidated because uh, you're in check. So if I have a king on e4 and I try to move into check, for example, so if I do move e4 to, I have to create a black piece here. So let's put a black piece on rook on f8. So I'm not able to go from the E to the F file, so I'll just try to move into the F file, so F4. So this should be equal to blank. So you should not move into check. And um, okay, actually, I'm missing a paren here somewhere. Okay, there you go. Okay, and another is if you have a king on E4 and rook on F8. Well, I guess I could have copied this, but let's say I have a pawn on A2, and I make the move the pawn, so A2 to A3. This should normally be a legal move, but because it leaves, actually the king is not in check. I'll put the king on F4. Okay, so the king is on F4, rook is attacking the king, but I move something else instead. So that should give me an empty list. So let's go make this pass. Oh, wrong number of arguments, 2 for 1. Oh, that's because of move. It's move piece. Okay. All right. Oh wait, am I in the move piece area? Or move? Okay, so I think I'm in the move area. Actually, let me see. This is getting so long that I think I want to turn on folding. So set FD method to be indent. Okay, so now it's all folded. Okay, so and let's take a look at the position. And okay, so this is, all right, so this is much easier to navigate. So let me see, I believe we were in move and we want, it's a move piece test that we're doing. So here are all the contexts and validate for check. This thing needs to be moved. This is really a move piece item. And so actually I can, all right, I close that up and open this up and put it at the end. Okay, so, all right, so I'll, I'll just leave it like everything else without the context. Okay, so you can't move into check. I guess I could break this up, but they're usually just 1 or 2 moves, so, you know, okay. Much easier to navigate. All right. All right, so let's see. Okay. Uh, actually, move piece returns. Interesting. So move piece Oh, move piece returns a position. Okay, so let's take a look at move piece. What does it return? It returns self. Okay, I guess the or nil. Okay, so it returns itself or nil. All right. One of the problems that I have with this code is this. The logic of this is kind of convoluted because when I go into move king, I have all of this stuff, but um, it's kind of confusing what it really, there's no unifying theme, it seems like. So if I go back here, um, like move rook, what is it returning? And it returns nil if, I assume like it returns nil if it's an illegal move. Um, but I kind of feel like um, somehow it should be raising an error or something, or at the very least, the logic of these are negated, and which is not the same way that I'm thinking. So really, and some of these are functions and some of them are not. So I think I want to make this a little bit more uniform by making all of these into functions. So I'm going to have a thing here called move knight, and just move this. Um, I'm not going to create a test for this because all I'm doing is it's just moving pieces around, and the testing already happens within the main code anyway. So I don't need to put that in there. Okay, so I'm just, okay, and move knight. And right now it should be from, to, and nil, but I'm going to change all of this. Okay, I'm going to change the logic of this. Actually, this one doesn't return nil. And okay, so this one is move bishop. Actually, the whole thing about calling it move is incorrect. So I'm going to have to change the name of this too. But for now, I'll just keep it this uniform. And okay, this is queen. Should move queen from, to. Okay, so this is one of the things about programming that I've noticed, that it's very easy to start writing code in the beginning without a laid out structure because it's small enough that you could wrap your mind around it. But once the complexity of the code starts to grow and you start to add stuff to it, then you really have to consider organizing things a little bit better because you're coming to it over and over, and your code should be very clear about exactly what you're doing. And this really isn't, because why is this returning a nil? And and why am I doing a validation when I'm trying to make a move? And so it's all confusing, and I don't like this. So I want to clean this up first before I fix the actual problem. So let's see. The first thing I want to do is I'm going to take away all these nils, and it's just going to return true or false. And these this actually should just be about actually the problem with this is that it's trying to do two things. One is validating the move, and the other is to make changes. So like updating the status. So for example, for the pawn, if I move a pawn 2 squares, then I set the en passant square. And if I castle, then I remove the ability to castle in the castling instance variable. So there's actually two things going on, and um, I think that it's I suppose it's fine if it's doing that, but it's the reason why I think it's fine is because if I don't want to break this up into two different functions. So basically saying if this is true, then handle. Actually, is that something that I really want to do? Because that is something that I could do. Have two different functions, one to validate and one to actually make the moves. So basically what that means is in here, for example, the king, you have two parts of this. The first part being is that you have conditional statements. And depending on the conditional statements, you have actions. But it's not all the same actions though. So then you'd have, so in the second part, if I had just broken it into two parts, then I still have to do the validation check because I don't know which situation that I'll be in. So it's best to keep it together, keep the logic and the move together because they're kind of intertwined. So if I, for example, if I want to see if the king move is valid and it's a queenside castle, then I want to make sure that the move that I make is a queenside castle, and I don't want to do that logic twice. So I want to keep it. I do want to keep it, but I think the difference now is actually from to en passant, all of this stuff. I don't. Okay, and these there are some rules that are universal, and these are universal. And I think I'm also calculating a dx and dy, and I think I should also pass in dx and dy as well. Okay, so I'm passing in that as well. Just because I don't want to keep on recalculating all of this every single time. But I do calculate the piece though. Then I would have to pass in the piece. Actually, I changed my mind on it, and I'm going to take them out and do it individually. The reason is because it's just a matter of code. It doesn't change the execution because that calculation is only done once. Because once it determines it's a rook, then it'll do it. So you're not actually duplicating the execution, you're just duplicating the code, which is fine for me. And from to, this is also universal. So whenever you move piece, it will always do this. So I'll keep that up. And this is also another universal function that all of them have. So I think I'm going to keep all of this. Okay, so and this whole statement, I'm going to take out this and make this return a boolean instead of a nil. So it's going to return a boolean to say whether or not it was valid. And so if it returns false, if it's not, then I want it to so okay, I can assign this to a variable, for example. See, okay, so I see if, okay, so valid. Okay, and this just says whether or not it's valid. And let me just align these. Okay, so now I know that it's, okay, I'll call it is valid because it's a boolean. Okay, so return nil if not is valid. Okay, if it's not valid, then return null. Pretty simple. And we have some of these other conditions here, and from to. All right, so then let's go change the code, move rook and all these things. The first thing we have to remember is that we have to change the logic. So here's move pawn, and actually, yeah, we'll just keep it like this. Okay, so we have the setup and en passant. So this handles the en passant. So okay. If it's en passant, then we do this, and okay, so that means everything's fine. In the else case, we'll return false. So we're just going to assume that. Okay, so let's see. This is fine. Move forward. Actually, oh, so this is just a condition. Okay. And we could just return it right here. Oh. So if we could return true because everything worked. Actually, we don't even have to say return true, do we? See. Okay. So this is return true. Actually, we'll make sure that we do a return on each one of these because they're separate cases. Okay, so there is no action being taken. This whole thing is a Boolean expression. So basically, I could just say return this, and I'll make this into a positive form. So move forward. So you know when to move forward if okay. Okay, so basically using De Morgan's law again, I'm going to reverse all of this. So all the nots becomes the affirmative, the positive form, and the ors turns into ands. Okay, so this should read a little bit better. Move forward. You move forward if so you're not moving side to side. So moving forward. Oh, dy absolute value is equal to 1. This is not so good because this also indicates that you should be able to move backwards, which isn't. And so I think I need to change this. So okay, so okay, if you're white, okay, if the piece is white, if the piece that you're moving is white, then the dy should be -1 if you're white or +1 if you're black. Okay, great. And or okay, so this is saying you could move. Interesting. Interesting. The reason why this is interesting is because the only time that you need to do something special is right here, which is en passant. We have to have a special move for en passant. But for, oh, this is really interesting. This is interesting because we should be able to tell whether or not you've made an en passant move. So this isn't necessary. So this whole thing can be just a Boolean expression instead of all this logic of if, return true, false. So interesting. I think I might be able to pull this out. If I pull this out, then this whole thing becomes one giant Boolean expression. And the reason why I'm doing that is so that it's easier to read. Okay, so okay, en passant. You're going the target square. You're going to the en passant square, and this. Again, I don't like this absolute value. I think this is terrible. This is terrible because this also allows you to go backwards. And it didn't occur to me this time around, but having fixed the bug that allowed a pawn to move backwards, it made me kind of sensitive to this type of problem. So this should really be more specific. So the dx, actually, this is fine. I got it confused with dy. So this means either side, and this is fine. This is what I was looking at, and this is fine. This is correct. Okay, so the movement is fine. All right, so and everything else, I can just say, I think I can just do this. Oh, why is this? Okay. I'll turn this into a big Boolean expression. Okay, so move forward 1 square. Okay, I'll just keep it simple. So it's actually okay. So I'll break it up into these different pieces here. So okay, dx is equal to 0, and this one is move 1 square. Move 1 square, and this is move 2 squares. So if you're moving 2 squares, then the dy should be, if you're white, then it's -2, otherwise it's regular, +2. And the from square should be the home square. This is move, and now let's put an or here and say move 2 squares. Okay. Return false if board 2 is not empty. Oh, okay, so so both of these, I could simplify this a little bit later, but I'll just do this for now. Board 2 is moving 1 square. It should be empty. Okay, false if, oh, this is really confusing, right? All right, good thing I'm rewriting this because the logic is so convoluted. If I have to think about it, then I want to change it. Okay, so the conditions for moving 1 square, it has to be empty. Actually, let's move this a little bit closer to the y part. Okay, and same thing. Oops. All right, we can group this and fix this up later. Okay, so that handles that part. And another condition is dy does not equal you're okay. So you're going forward. I think this is taking care of these two. Okay, and this one is saying it's a capture. Okay, so that is an OR part. Wow, I can't believe I wrote this code because it's terrible. So board 2 is not a dash. We don't have to worry about capturing your own piece because that's handled as a universal truth. Okay, so for the capture, this, okay, so it has to go sideways. This is what this is saying. And, okay, and then let's get rid of this. Okay. Whew. Feel like able to breathe a little bit. Okay, so you can move sideways. For the Y part, it's only one square. Oh, actually, this is already written here, so get rid of this. All right. So this is the condition. So put capture here. Okay, and all right, kind of like this. All right, so all right, this is already returning true. So basically, if we just handle en passant in a special way, then okay. So all right, let's just save this. Syntax error 94. So I see. Oh, okay. Take that out and put in. Okay, there you go. That's mismatched parentheses. Undefined local variable piece. Oh, 132. Okay, move piece. We do need piece, and we do need from and to because of these things. So okay, so it'll just be done twice. So actually, I can just copy it from here. Move queen. Huh? Where'd it go? Oh, that I think I deleted a little bit too much when I did that. Yank and okay. All right, argument error for move piece 240, move knight 121. Right. So, oh, this is really interesting because I don't need from and to. I just need dx and dy. So some of these require dx and dy. Actually, is it all of them? No, you do need to know from and to, and you also need to know the dx and dy. Okay, so just to make it consistent, I really don't like writing redundant code. You have from and to, and let's see, just put it right here. We'll do this for now, and then we'll refactor. Okay, so we have a knight on e4. Move e4 to c3 and return to nil. So knight. We didn't actually, because we need to have the positive form now. So we can actually go through each one of these. Okay. And all right, so let's go through each one of these. So we did move pawn. Let's take a look at move king, and we actually don't have to wait for the errors because we're just reversing the logic. So move king, nil, it's actually false, right? And return true. So if everything went smoothly, return true. The reason why, well, for this, there's so much logic in here that it's best to keep it this way, return false and return true. So the only time that you return false is if, actually, if it's, okay, so if you're moving into a really, if you're moving more than one square, then you have the castling situation. Other than that, you're fine. Okay. And because we're not worried about whether or not you're in check. Okay, so move rook. Okay, so move rook. This, oh, interesting here. So when you move the rook, you delete the ability to castle for that side, and the Boolean expression. And this code is not dependent, so we can take this and put it here. But this is totally garbage. I can say that about my own code. So basically, this should return whether or not the expression. Okay, so for a valid move, the test is the dx is equal to 0 or the dy is equal to 0. And I'm going to separate this a little bit. Okay, just get rid of two pieces of code. So we handle the the extra bit of code, and we run the test. Maybe we could do the same thing with the pawn, because this is really bothering me. This code, because like just looking at this code, it just looks like it's not very elegant. But I'll come back to this once I have everything running. Okay, so I have to fix the correctness first. Okay, so move knight. Move knight is fixed. Okay, so now this one we turn into the positive form. For the queen, we do the positive form, so use De Morgan's law again. Change all the ands to ors, equals to not equal, and vice versa. And this one should be an or. Okay, and move piece now. Now it's complaining about dx. Why is it complaining about dx? Actually, am I using dx at all? I'm using piece. Okay, I don't think I'm using this at all. So where's dy? Oh, here's dy for the en passant. Actually, this is, do I need the piece at all? Yes, I do, because of I want to check the color of the piece. Okay. And as for this, is this in the right place? Setting the en passant flag universally. Well, when do we need to set the en passant flag? Well, we only need to set the en passant flag if it's a pawn move. And so it's actually right here, pawn move, and the pawn has moved 2 squares. Okay, so that's very specific pawn logic, and I don't like having it here because it's just too specific to a pawn. So I'm trying to think of a way to set this up so that, because what I don't want it to do is to go through each one of these piece movements and it's okay. This is struggling. Okay, for now I'm just going to keep it because we need to make this thing pass. Undefined local variable dy. That's because I removed it. Put it back. Actually, it says dx is not used, so let's just put an underscore there. All right, so this is a this is the problem that we were trying to fix. So we have a king on e4, and it's trying to move into check, and it should be empty, but instead it got something. So now we have to actually do a validation on check. Okay, so let's go to let's see, move. I think this might be it. I'm not 100% sure. Okay, so it is move because we have the list of potential moves. These are potential moves. And oh, this is really interesting. This is interesting because this can be abstracted away into another function called possible moves. So it gets you a list of all possible moves given a piece, because this is basically what it does. All possible moves, and this has the added condition that that the piece must move to that square. So eventually we're going to extract this into a function, and so we'll clean this up. And also, I hate this line. It just got too long, especially with the variables. So I can't wait to get this thing working so we can fix this. So what's the error again? Okay, so king going into check. Okay, so we need a place in here to do a filter. So select if, and then we'll do another select if. Actually, we want to delete if from. So we make the move equals yeah, we'll make a duplicate. Well, let's just say dupe, and try to do it in one line, but it's if it's more than two, maybe I'll break it up. But okay, delete if in check. You make the move and it's in check. All right. So there's the move piece. Oh, that's really interesting. That is really interesting because we can actually do it from here. Actually, okay, so many different ways that you could do this. Okay, so delete if in check. Okay, so if it's, but you have to move it. So dot move piece from two. Okay, so the reason why I'm having trouble with this is because I'm basically duplicating this in a way. And okay, what is this from? Temp board from. So, huh. Oh, it's. I was parsing this as if it was from here to here, but actually it's a Boolean condition. So this is what happens if you stare at the code a little bit too long. Okay, so as long as the it's equal to the piece, right? Okay. All right. So I like this for now. And see, failure expected. Oh, that's because I'm inside of, right. So basically what this is saying, is that it's going to be part of move piece, and I'm in move, and this is saying it's in the wrong place. And I think it's true. It's true because within move piece, this is where it should do the validation. So this checks to see if it's a valid move, like it's a legal move, and then return nil if it's not valid or in check. There we go. This is what we want to see. If it's in check, then nil. Right. So if you're not that the opponent is in check, but that you're in check after you've made the move. So in order for this to happen, this has to happen first. Like you have to actually move the piece. So this should happen right there. And oh, so if this is happening here, then this kind of wraps up together, doesn't it? So this is the same thing as saying, so let's put this in a positive sense. So so basically just saying if it's valid and you're not in check, then you want to, I'll just do it this way. If it's valid and you're not in check, return self, otherwise nil. Uh, I'm not really happy with this, but I just want to get it passing. Undefined in check. Okay, so let's write in check. Def in check. Actually, do I have, I don't know if I have, okay, so I don't have a test for in check. So let's close this up, and so we don't have it, and we want to make sure that in check is done before we do move p. So we'll put it right here, context in check. Okay, so let's set up a position. So all right, so we have a position here where the king is on e4 and there is a rook on e8, so it's right down the line. And the question is in check. This is white's turn, so it really depends on whose turn it is. So in check, actually we can say it's in check should be true. Yes. Actually, I'm going to do it in a different way. It expects position king e4, rook e8, check, in check, to be true. So I'll just do it in one line instead of two. So this way I can have more than one. All right, so let's see. And if I have a new position, so brand new position, and I say in check, it should be false. Okay, in check to be false. All right, so we have 1, 2. Okay. Actually, let's put a knight hitting the king as another test. So knight has to be on c3. Okay, so the knight is able to hit the king in check to be true. And let's do another one for, actually, we'll take both of these and just flip it so that it is a white rook on e8 and a black king. So, and we need to say it's black's turn. So turn is black. Okay. And okay, so knight c3, king e4. Okay, and we say turn is black. Okay. All right. I'm pretty happy with this. Okay. All right, so let's see. Now we have to write in check. Actually, if I wanted to be more comprehensive, I would have made sure that all the other pieces would be able to attack the king. But that would be a redundant test, because really what you're checking is rechecking the piece movement, and I've already done that. So if the logic holds for one, it should hold for all of them. So okay, so my code should not be that fragile. If it is, then I would probably have to rewrite a large chunk of it. Okay, so we need to create, okay, this code too is getting quite long. So I think what I'm going to do is fold it. Set the fold method to indent. Okay, so now I have these two position. Okay, so we have all this. We have move piece. What we're trying to do is, I might as well, I want to keep all the moves together and in check. For now, we'll just leave it empty. So that's the same thing as false. All right, so let's do the check. And the check should be fairly simple. So it depends on the turn. So let's find the king index. Where is the king located? Well, if you take a look at all the indices and you select IDX, board IDX is equal to, if you're white, so based on the turn, we're going to look for the king, otherwise black king, and that's it. And that should actually, this should either get, actually, well, let's just say list. And if the list is empty, so how do we want to treat this? If the list is empty, do you want to, you're not in check, so that's, I'll just say false. If it's not empty. Okay, so if you have something, what if you have more than one king? Let's not assume that. Let's just assume, let's just do a check on the first king. So list of 0. So, and you want to see if that's in check. So the way you can do this is by going through all the possible, well, you have the king position. So this, the first thing we want to do is find the king position. This is the king index. All right. So mission accomplished for that part. So once you have the king index, you want to go through looking for what can attack the king. So you have all the pieces. So opponent pieces would be opponents. Okay, is going to be the set rook, knight, bishop, queen, king, pawn. So these are all the pieces that are available. And we're either going to upcase it or downcase it. So depending on whose turn it is. If it's white's turn, then we want to look for black pieces, so we want to downcase. Otherwise, we want to upcase. All right. Opponents and cars. So this way it's enumerable. So now we can say opponents dot see map oh, actually, we don't want to say map any. If any of these are true, if any of these opponents are able to, I'll just say opponent, because I don't want to say piece, because that implies it's your own piece. So I want to say it's the opponent piece. So it's opponent. So you have an opponent, and you want to see if move piece from to, oh, actually, the condition here is actually I misspelled opponents. Okay. Okay, so if I realize that this is probably not the right way to approach it. The right way to approach it is to also go through the indices again. Indices. And then you say any. Okay, so you have a from. So basically what you want to do is from move piece from this to the king. So are any pieces able to, oh, if it's your own piece, then it would be false, and if it's an empty piece, oh, so we don't even need to have opponents at all, because implicitly the logic is built into move piece, because anything where it's not your opponent's piece, this is okay, this is good, because this will eliminate all your own pieces from moving, and it'll be your opponent's piece. Okay, so actually we don't have to think too much about of the logic, because the test will bear it out. Undefined method, oh, interesting. Percent for nil class. So this is where the king, oh, the reason is because the king index select, this is going to be a list of indexes, and it could be empty, right? Oh, let's see where it's actually failing. It's failing on line 18, 142, 142. Let's see. Okay, this is 142. Huh. This is one of the problems with folding, is that when you fold it, then the sometimes the parsing gets kind of screwed up. Hmm. Just kind of curious. That's fine. Just move it one. Okay, so Z capital M, Z more, ZR, ZR. Okay. Let's go to move piece. 142. Okay. What is this error? It says 142. 142 move piece, XY diff. So, oh, interesting. So that means that it thinks that one of these is nil, from or the two. So okay, so this is where we were. So one of these is nil, and I know that it's not the from, and it also can't be the king index, because actually let me comment this out, and let's say this is true. Okay, got true. And interesting. So I'm actually going to print this out. from king index inspect. Okay. Oh, this is interesting. This is a nil. This is unexpected because there shouldn't be any way. Oh, of course. I said false. I forgot to return. Okay, that explains why. Because otherwise, king should never be nil, because the return would happen right here. So, right, step can't be 0. Oh, interesting. Right. Okay. So the reason why this happened is because inside of move piece, from and the king index may be the same, so you try to move to the same square. So in move piece, I'll put that as a condition. You can't move to the same square, and it'd be a good idea to write a test for that. So here, I'll just put it. Oh, actually, this won't get there because in check is all the way here. They're kind of dependent on each other. So move piece would depend. Well, okay. So I'll just fix it, and I'll just put it. You can't move to the same square, so I'll just put it here for reference. Move p should equal nil. So b nil, and it is position. I don't know, king e1, and I'll say move e1 to e1. Okay, so you can't move to the same square. That error is not going to be run right now, but move piece return nil if from is equal to 2. So you can't move to the same square. And I'm doing this before we do xy diff. And it'd be good to, for the xy diff, interesting. XY diff. Step. Okay, 2 for 1 in move 120, 194. So let's go to 194. Oh, what's the error? It's on 194, but it is 75. 75 is the 75. It's right here. Okay. Oh, because it was supposed to be move piece. Okay. Interesting. In check. Okay. So I expected the position king e1, h1, so basically it's trying to castle. And when you castle, oh, look at that. The king disappeared. There's no king. How did that happen? So let's take a look at move king. Actually, it's considered a king move. Oh, right. Let's see. So the rook has moved. The rook has moved where the king should be because the king is 1 square away from the end. But now the rook is 1 square from the end. So this is wrong. There's something wrong here. It is the castling on the king side. So let's take a look at the castling on the king side. And that's considered a king move. Okay, so there's some logic that is wrong here. So it's on the king side. So this is on the king side. We want to move from H to F, white piece. Okay, and take a look at move piece. Okay, is valid, in check. Okay, this problem wasn't happening, so it must be somewhere close to an assignment statement. I could step through the code. Let's see if it's worth stepping through the code. Looking at the error again, it looks like yeah, I think we would benefit from stepping into the code, because here's move piece, and yes, let's do that. Because we have the exact spot of where the error happened, and it's right before this we could set the debug. Okay, so it's with the castling. Okay, let's go check it out. Castling. Okay, actually we have to go to the spec. Okay, it's this one. So we'll just put a debugging statement here. So tap. We don't need it. And just say debugger. Okay. Dot. Yeah, let's just do next twice. All right. So move piece. Okay. So okay, let's print out what the piece is. It's a king. Okay, so far so good. Okay, step next. Finish. Finish. Okay, so okay, and valid. So we step through this one. We go inside. Okay, piece. It's still a king move. And let's print out what the dx is and the dy. That is, so far everything is correct. Okay, now we have the condition about testing to see if it's a kingside castle, and it looks like yes, it's a kingside castle. So move piece. It's going to move h1 to f1. Let's print out what it looks like. So put as self. Okay, so this is good. The king is right there, and let's see what happens if we try to decide whether to step into it or I'll just say next. Okay. And okay. Wonder. Okay. I don't know where I am anymore. Okay, so this is where we are, and it hasn't changed. Okay. Oh, this is the case for the rook piece. Okay. For some reason, I'm not able to like step over a line, so I have to go in it sometimes. Okay, so let's just finish this. Okay, so in check, I'm in check. Oh, this is interesting. P self. Okay, so it's the rook. Interesting, because where's the king? Um, hmm. This is extremely bizarre. This is a very interesting. Oh, indices. Oh. I totally know what's going on here now. I'm gonna quit out. Okay, I know exactly what's happening. And this is a problem with uh, programming like this. This is why I do functional programming, or I prefer functional programming. The problem is that even though you're testing this out, let me just quit out. Let me just go back to the code where in check. Okay, so actually in check. Here we go. Okay, indices in check, um, move piece. Select indices. Okay, the problem is right here. The problem is that you're actually moving the piece, and this is destructive to your state. And so basically what you really need to do is you need to create a temp here and dupe. Oh, actually, you can just do dupe move piece and see what the result is. Yeah, this would actually work. And it looks like we're past that error now. Is king uh, with a rook on f8, we try to move the king into check. Okay, so this is okay. So you move the piece. Okay, to f4. Okay. So I feel really awkward about move piece now. Because on one hand, we do want to have side effects. And the side effects with move piece is necessary because, well, in our case, um, because we do want to change our state. Uh, hmm. Okay, so let me stop being so philosophical and take a look at this now. Okay, so oh, this is actually correct. It's just that I'm returning nil. Move piece would return nil, and it was expecting. So I think this is move piece. I think this might actually be correct. It's just that I'm doing this b nil, move piece. Oh, this is so. This is really screwed up because at some point I'm comparing it to a list. And actually, this is completely wrong. Then I should not be comparing this to an empty list. I should be just saying b nil, because that's, so if it's an invalid move, then it should be nil. Okay, so the test was wrong. Okay, so I'm at this next phase here. Okay, so that's because I have equal in here and need to just be this. All right, so we're past that point. And I'm not really sure how much time I spent on this one issue. Oh, actually, this one is very simple because it's just a form error. We're not reading in the rank. So we can just modify this. This is a very simple problem, and so I can. Okay, so okay, now I want to turn off folding. So ZR. Is it ZR? Z capital R? Okay. All right, so the problem is in move because that's not part of this. So we want to say this, or it also contains, okay, so now because it's getting long and white space is our friend, we can just move this all over so that it'll fit. Not sure how, okay, so we'll fix this up. Okay, so I'll just put it like this. It's called the rank, and that's 1 through 8, and it may not be there, and it might be takes. Okay, so rank. So we have, so basically all we have to do is look for column. Here's column, and we do the same thing except we do it for the row. 2 row M rank, and list select from where, from, now it's like the row, so equal to row if the row exists. And now we just need to define row. Go here, Z capital R, okay, row. To row of, actually, let's see, to row of 1 should be 7. Okay, to row of 8 should be 0. Okay, let's go make this. Okay, let's make this real. Def. 2 row string, return nil if the string is nil. Okay, so the code for this is 8 or minus stir that or. Yeah, I'm doing this just in case, like later on, if I wanted to put in like an A8, for example, it'll just pick the last entry. All right, so far so good. We didn't break anything. Okay, it's going good. Slowing down. Oh, rook takes A1. Okay, I wonder how far it got. So if I run rspec now, okay, 20, 30, 40, 50, so far so good. 70, all right, 75. So we went up to game 75 before we got an illegal move, rook takes E1. So, oh, this is interesting. Oh, the reason is because pawn promotion. So there's something wrong with the pawn promotion. And I think I think I know what the problem is. Yes, I think I know what the problem is. All right, so let's try to do a pawn promotion. So let's see, black piece. Okay, this is actually done correctly. So when it did bishop takes a1 equals q, so here's the pawn, and I have to inverse this because I have a black background. So it is a black piece, but look, it's a white queen. It's hard to tell, but if you go in closer, it's a white queen. So I'm putting in the wrong colored piece. Okay, so let's go fix that. That should be a very, very simple problem. So we go to move pawn. Okay, so we know it's in move pawn and is not en passant. It is the pawn promotion. Oh, it's not even in here. It's part of move because it doesn't have to do with the movement itself. So tag move. Oh yes. This thing. I'm gonna set wrap. It's no wrap. So this way, okay, and let me see how this is. Okay, so let me just fix this, and I think I'll call it quits for this session. Okay, so promotion. Let's look for promote. There it is, promote. Right, so here we're setting the piece, but we don't actually say what color it is. And by default, it's going to be white. So, okay, so if the piece, okay, so depending on the piece, if it's white, we want to upcase it, and otherwise we want to downcase. Okay, we're doing this quite a lot, so and this is quite a long piece of code for one concept. Anyway, this should fix the problem. So we got up to, I think, game 75. Let's see how far we go this time. Oh, we passed it now. We're at the 80s, 90s, hundreds, 130, 142. I think it's going to finish. It went through all the games and everything passed. So then it's a very good time to end this session. Okay, so let's take a look at what we've done so far. I believe I'm not really 100% sure, but I think we were getting close to 300 lines of code last time, but now it's 230. Plus, this code actually does more because it has it prints out this, and this is an extra 20 lines of code. And there are other things that it did in addition to what we had last time, our version 1 of the code. So I like this a lot better, and now that everything is passing, I can feel a little bit more comfortable about trying to fix this up. And this time around, I'm not going to rewrite it from scratch, but I will want to refactor this because there are a lot of places where it's hard to read. And so I'll reflect on this, and for the next session, I will try to make this so that it's a little bit easier to read, hopefully simplifying certain things and try to organize this a little bit better. So see you next time.